Okay. Okay, guys, let's finish this test. Okay, so here they're asking you find the 5-number summary and construct a box plot, right? State whether there's any outliers and briefly describe the distribution, skew to the right, skew to the left, or symmetric. Lastly, find the mean and the standard deviation. Okay, so this is not bad. The only thing we need to do is plug these values in the calculator and basically we're done, right? So let's do that. Let me do that here. Let me share this with you. Okay, so let's do that. Let me clear this data. Clear this up. So we have 86, then we have 84, then we have 72, 73, and 84. That's the first thing, right? 86, 84, 72, 73, 84. Then we have 91, 73, 74, 95, 86. Okay. Then we have 79, 96, 70, 83, 84. Okay. Then we have the other row, or the, I'm sorry, the other column, 77, 79, 88, 85, 80. So now we do the next, 85, 84, 67, 98, 90. Next, 81, 93, 99, 54, 77. 99, 54, what happened here? 99, 54, 77, then 73, 89, 78, 87, 84. Next, 62, 90, 82, 85, and 73. Okay, so now let's check all these values really quick. Okay, 86, 84, 72, 73, 84. Okay, 91, 73, 74, 95, and 86. Then the next value should be 79, 96, 70, 83, 84. That's correct. And then the next should be 77, 79, 88, 85, 80. Then the next should be 85, 84, 67, 98, 90. Let's check again for the next. 81, 93, 99, 54, 77. Let's check again. 73, 89, 78, 87, 84. And let's check the last values. 62, 90, 82, 85, 73, and we're good. So now we go to stats, calculation, right? And we have the mean right away. The mean is X bar equals 81.8. I'm gonna round it. Standard deviation of the population here this time, because this is the population of students, right? There's 40 students in this class, and this is their final score, so it's all the students. So that's the population. So this is 9.4. Okay, and now we need to find the 5-number summary, right? Minimum, max, right? Q2, Q1, and Q3, right? Okay, so let's find out the rest, and we're almost done. So let's check. So the minimum is 54, the max is 99, Q1 is 75.5, Q2 is 84, Q3 is 87.5. Now let's go back to the slide really quick. Okay, so I have already my my Q3, and I can find my IQR, right? So IQR is Q3 minus Q1. So Q3 is 87.5, Q1 is 75.5. So the difference between those two is 12, right? That's 12. Okay, so that's the IQR. And they want me to find, they want me to draw a box plot in if there's any outlier, right? That's what they want me to find. So I'm gonna move this out. So I'm gonna put this here. I'm gonna move this here. I'm gonna move this here. And I need to find the IQR. I mean the outliers, right? So the outliers is Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. So Q1 is 75.5 minus 1.5, the IQR is 12. Q3 is 87.5, 1.5 times 12, right? And compute, right? 75.5 minus 3 halves, right? So that's 6, 18, right? And 87.5 plus 18 again, right? 3 halves is 6, 18. So this is 75.5. So that would be 70, 60, 55, 57.5, right? And this one would be, what is this thing? 104.5. 105.5, right? Let's double check, just in case. So we can make silly mistake, right? And then that everything is wrong. No, that's right. Okay. Just in case, let's check. Okay. 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 All right, let's see. I want to make sure I have everything correct. 1 second. Okay. That's, everything is correct. So let's, okay. So clearly the only outlier that we have here is the 54, right? The score of 54, because that's out of this range, right? So if you see this range 57.5 and 105.5, there's no number above in this data above 105.5, right? So but 54 is below 57.5, so that's an outlier, the 54. So you can say the score of 54 is an outlier, right? Okay, you can say like that. Now we need to find they want you to find the distribution, right? They want you to do the box plot. So the box plot is easy, right? You can just do something really quick. You can say the minimum is 54 here, right? So this is 0. Let's assume the 54, let's say, is around here. Doesn't have to be, you can just do quickly. 54, 99, it's a max, right? The median is 84. Let's assume that the median is 84 around here. And the Q3 is 87.5. So you can see clearly that this graph is skewed to the left, right? Left skew. So you can do this. Okay, something like that. And you can see clearly that this is skewed to the left. Okay, let me, if I move these values more, sorry, if you move these values more, you can see clearly that this is the graph. Let me move this box plot here. Yeah, this is supposed to be around here. 7.5. Mean is 84, so it's about here. So let me move this stuff. 84 maybe around there. Let me erase this stuff. The 84, let's say that's around here. 87.5 around here, and you can see clearly that the distribution is skewed to the left, right? Left skew, right? Or something like this, right? So left skew, and you can say, okay, left skew, right? Left skew. The distribution is left skew. What else I want? You have the mean, the standard deviation, the box plot. Now you said that this is the outlier is 54, the score of 54, and that's it, right? That's it. You're done. That's it. So make sure when you're typing in the data, make sure that you double check, and that's pretty much it, right? Next number. So this is probability, right? So that's what we did last, I think that 3 weeks ago or 2 weeks ago. So events A and B are mutually exclusive. So you know what that means, right? Mutually exclusive means there's no intersection. That's what that means. So the intersection is 0, right? So you have event A or B, right? So the probability of A union B, or I'm sorry, the intersection is 0, right? Therefore, if you use the addition rule, the probability of A union B is the probability of A plus the probability of B. And since the intersection is 0, then that's it. So they're asking you if events A and B are mutually exclusive, find the probability that is missing. So the probability of A union B is just the sum. So 1/5 plus 1/2, right? So this is 0.7, right? Because this is 0.5, this is 0.2, this is 0.7, or 7 of 10, right? Right? You do 1/5 plus 1/2. You need to find common denominator. You multiply here by 2, and you multiply here by 5, right? And you get 2/10, and then here 5/10. So that's 7 out of 10, right? Same thing. Okay, so that's how you do that. So that's the answer for part A. Okay, very easy. Next, they're asking you determine if events A and B are independent. Independent means the probability of A intersection B is the probability of A times the probability of B. Probability of A intersection B, if they're independent, this is the definition, right, of independence. And obviously, because this is true, if you think about conditional probability definition, the probability of A intersection B is this, right? Since these are independent events, the probability of A intersection B is the probability of A times the probability of B over the probability of B. So this cancels out. Therefore, you can say the probability of A given B is the probability of A, right? Likewise, the probability of B given A is the probability of B, right? So these are just as a result, right, of the first of the definition. This is also true, right? So you have to understand that. Now that you understand these rules, right? So these are my 3 rules. Let me this box. Now you understand that. They say determine if events A and B are independent. So they give you the conditional probability, and if they're independent, the probability of A given B should be equal to the probability of A, right? Because that's what my axiom states, right? If they're independent, this must happen. So they give me this, and this is not true, right? So I can say they're not independent, or not. But let's double check by multiplying the probabilities, right? So you say the probability of A times B should be equal to the intersection, but we don't have the intersection, but we can find it, right? If you want to do the long way, right? So the long way will be what? The probability of A given B, you have that, is the intersection over the probability of B. You have the probability of A given B, and you have the probability of B, and that will give you the intersection, right? Okay, so A given B is 3 over 20, 3 over 20, and then the probability of B is 2 over 5, so that's the intersection. So that's going to be 6 over, or you could, yeah, 6 over 100, 6 over 100, and if you simplify that, that's 3 out of 50, right? That's the A intersection B. So this is 3 out of 50, and probability of A is 1/5, and the probability of B is 2 over 5. So that's going to be, you multiply these two, that's going to be 2 over 25. So that's not the same as 3 over 50, right? So therefore, they're not independent. But you could avoid doing all that work just using this second case, right? So probability of A given B should be equal to the probability of A if they're independent, because B has no effect on A, right? So that should be equal to the probability of A, but because they're not independent, that's not the case, right? Okay, so that's how you do that. So remember these cases, so it will help you and save you time. You have to compute these things. Okay, this is independence, right? Put that in green. Okay, actually I should put dependence, not dependent. Independence. Okay, make sure that you remember that. Okay, so we said that these are not independent, right? Not independent, because we already compute that, right? Okay, what about this one? So if they're independent, that means the probability of A given B should be equal to the probability of A. So here we have the complement, right? So this is the complement. So to find the probability of A, we do 1 minus the probability of the complement. So this is 1 minus 1/2, which is 1/2, right? So probability of A equals 1/2. So what is the conditional probability is 1/2, and the probability of A is 1/2. So that's true. So these are independent, right? You want to do the long way again, you need to find the intersection, right? So to find the intersection, you need to multiply the probability of, you need to do all that work, right? I'm not gonna do it because, well, let's do it just in case for you to understand everything. A given B is the intersection, right, over the probability of B. So you cross multiply. So A given B times the probability of B is the intersection. So the probability of A given B is 1/2. The probability of B is 2 over 5. So that will be the intersection. So this cancels out and you get 1/5. That's the probability of A intersection B. Okay, so that means that the probability of A times the probability of B should be equal to the probability of the intersection. So probability of A is 1/2. We already calculated that. And the probability of B is 2/5. And the intersection, I mean the A intersection B is 1/5. So you can see you get 1/5 again, right? 1/5 equals 1/5. But you don't need to do that if you know, the second case and the third case, right? You don't need to do all that work. So it's redundant to do all this work. You just need to know the case, right? So if you know this case, then you will save a lot of time, right? Okay. If you don't remember, just keep in mind this. What this means when you have independence means that this guy, this means A given B, right? Given B, right? So that means given that B already occurred. So that means that this B has no power on A, basically, right? It has no effect. So whatever B is doesn't matter. It doesn't affect A at all. So because it doesn't affect A at all, the probability of A given B is just the probability of A. And likewise, the probability of B given A, because A has no effect on B, that means that this is B, the probability of B. Okay? Just keep that in mind. Just remember that. Okay? And one more thing, A given B, it's not the same. It's not the same as B given A. Just keep that in mind. Okay? It's not the same. Especially remember when we were doing base rule, we know that these are not the same probabilities, right? So just keep that in mind. Okay? Okay, so that was that case. Okay, here, events A and B are independent, find the missing probability. So if they're independent, you know what's going on, right? The independent, B has no effect. I mean, A has no effect on B, right? So the probability of B given A, it should be the probability of B should be equal to probability of B. So that's 7 out of 20, right? So if the probability of B is 7 out of 20, the probability of the B complement should be equal to 13 out of 20, right? Just the complement. So the probability of B complement is 1 minus the probability of B. 1 minus the probability of 7 over 20 is the probability of B. 20 out of 20, finding common denominator here, meaning that I need to multiply here by 20 over 20, that 1, right? And then this is 7 over 20. This implies that this is 13 over 20. That's what that means, right? So that's why I get the answer. So this is the answer, right? This one right here. This is the answer, which is the same as this, right? I'm just showing you the computation here. Okay, so that was that. And let's do this thing. This is the thing that you kind of little bother you, right? It's difficult a little for you. Okay. Here they're asking you. Let me move this thing somewhere else. Okay. So here they're asking you, find the probability. A factory production line is manufacturing bulbs using 3 machines, A, B, and C. Of the total output, machine A is responsible for 25%, machine B is responsible for 35%, and machine C is responsible for the rest. It is known from previous experience with the machines that 5% of the output from machine A is effective, 4% from machine B, and 2% from machine C. So basically, those are the probabilities of defective coming from their respective machines, right? Those 3 machines. A bolt is chosen at random from the production line and found to be defective. What is the probability that it comes from machine A, B, and C? The main thing you need to understand is what the base rule is telling you, right? This comes from the definition of the conditional probability, right? So the probability of A given B is the probability of the intersection over the probability of B. You need to remember this so it makes your life easier. So then the probability of B given A, which is not the same as the probability of A given B, is the probability of the intersection over the probability of A. So if actually, let me make it this way so you can understand. These 2 statements are the same, right? Think about the Venn diagram if you're confused. So this is A and this is B, right? A and B. The intersection between A and B, let's say I have 1, 2, 3, and let's say 4 is the intersection, and 5, 6, and 7 here. So you know that the intersection between these 2 sets A and B is 4, right? Meaning what? Meaning that the intersection of A and B is 4. That B intersection A is the same intersection, right? Because we're talking about the same two sets, right? So that means that this is also 4. So when I'm telling you the A intersection B or B intersection A is the same thing, right? Okay, so if that's the case, then that means that if I cross multiply the second side, right, here, if I cross multiply by this side here, like multiplying both sides by probability of A, so I get the probability of B given A times the probability of A is the intersection, right? Meaning that I can replace this, this green, this right here is the same as this, right? So that's exactly the same thing. So instead of putting that here, I'm gonna replace it with the probability of A given B with this thing right here. So this is the probability of A times the probability of B given A, right? And this is over the probability of B because the probability of B didn't change. This is this part right here. This thing didn't change at all. The only thing that changed is the green part, right? Using substitution, basically, right? So that's what happened here. Now that you understand that, this denominator is the low total probability. Okay, now you need to understand what sample space, okay? So sample space is the universe, right? Everything that is happening here. So we can think about in terms of partitions here. We have A, we have in this particular example that they give you, we have three possible situations, right? Or the events, right? I'm sorry, that you have event A, the company A, B, and C. I'm sorry, the machine A, B, and C. So those are the sample space is divided in these three cases, right? And then you have an event of defective, right? That's what they're asking you, right? So defective should be the overlap between these three machines. So this is defective, this is the event defective. So what they're saying here is, if you think about it, the sample space, right, is the union of these events, right? So it would be A union D, B union D, and C union D. But if you think in terms of the probability, not to make the story too long, right? So the probability of defective, if you think about just defective, it should be the probability of A times the probability defective comes from A, right? Plus the probability of B times the probability defective comes from B, plus the probability of C times the probability of defective comes from C. So that's the low total probability. In this case, that will be your sample space, right? Because the event here is defective. So meaning, in this problem, they're asking you, they said, a ball is chosen at random from the production line and found to be defective. So we're talking about defective, it should be the denominator, right? And what is the probability that it comes from machine A? So if they're asking me, the probability of the defective comes from machine A. That's what they're asking here, right? I'm sorry. They're asking here, what is the probability? Is it a ball is chosen at random from the production and found to be defective. So given that it's defective, I'm sorry, given that it's defective, it comes from machine A, right? So that's what they're asking. And here they give you the probabilities, right? So when you're doing this, you need to find first basically the simple probabilities, right? The probability of A, probability of B, probability of C. And they give you that in the problem. If you notice that, they say A, B, and C, of the total output, machine A is responsible for 25%. So 25% comes from A, right? And then machine B is 35%, so that's 0.35. And the machine C for the rest. So remember, the sum of the probabilities must be equal to 1. So here I have 0.60 if I add the probability of A plus the probability of B. So that means that the probability of C should be 0.40, right? That should be the probability of C. Now you have A, B, C. Okay. Now that you have that, they're giving you the conditional probabilities of this problem. So let me put that in a different color. So the probability, they say here, it said it is known from previous experience, this part right here, if you read, it is known from previous experience. Let me highlight that so you can see what's going on. It said it is known from previous experience with the machines that 5% of the output from machine A is defective. So given that is defective comes from machine A is 0.05. Then they said 4% from machine B. So given that is defective comes from machine B is 0.04. And given that is defective comes from machine C, right? Is 0.02. Do you see how I'm writing my probability? So this is always going to be the case. You're going to have the, your normal probabilities, and you're going to have your conditional probabilities. Okay. And make sure that when you read carefully. Okay. In this part that I highlighted in green, it is known from previous experience that with the machines that 5% of the output from machine A is defective. So given that is defective, right? Because they're saying it's defective, you know what's happening with the defect, right? Given that is defective comes from machine A. So the defective should come, it already occurred, right? Because they're telling you the problem that is defective, right? Given that is defective comes from machine A, you know it's 0.05. Now, and the same thing applies for B, and the same thing applies for C. Now, the final question is, what is the probability that they said a bolt is chosen? Let me highlight it so you understand the question. They said a bolt is chosen at random from the production line and found to be defective, right? What is the probability that it comes from machine A? So given, they said, that bolt is chosen at random from the production line and found to be defective. So given that is defective, what is the probability that comes from machine A? So that's the right probability. And notice that this is the reverse of this one, right? Right? Is the reverse. I'm sorry. I don't know why I put it wrong. So here they said a ball is chosen at random from the production line and found to be defective. What is the probability that it comes from machine A, right? So if you, at this point, if you don't compute it right, just make sure that the probabilities, they have to be the reverse. So if they give you this, right, then the case should be like this, okay? If you get confused at any point. But let's read the problem one more time, right? They say, it is known from previous experience with the machines that 5% of the output from machine A is defective. So given that is defective comes from machine A, right? So the question is asking you from the production line, a bolt is chosen at random and found to be defective, right? What is the probability that it comes from machine A? Okay, so it is known from previous experience that 5% of the output from machine A is defective. Okay, so I think I made a mistake here. It should be A, given that comes from A is defective, given that comes from B is defective, and given that comes from C is defective. So that's the reason I always tell you, read this problem like 2 times or 3 times, so you make sure that you do it right. So now it's okay now. Now they're asking you, what is the probability that it comes from machine A? So given that it's defective, right? Given that it's defective, because they're saying that in the question, a ball is chosen at random from the production line and found to be defective. So given that it's defective, what is the probability that comes from A? Right? So now it's a reverse, you can see that, right? Make sure that when you're doing that, you read the question carefully, okay? So now you do the probability, right? So this is the probability of A, times the probability of D given A, right? You just apply the formula, right? And this is the probability of A times the probability that is defective comes from A plus the probability of B, given that is defective comes from B, and the probability of C, right? Given that is defective comes from C. Yes? So now you do that. And that's one of the answers, right? So what is the probability of A? Is 0.25 times the probability of B given A. So that's 0.5 over the probability of A times the probability of B given A, so 0.25 times 0.05, and the probability of B is 0.35 times the probability of B given B is 0.04, plus the probability of C is 0.40 times the probability of D given C is 0.02. And now this is just about computation, right? You can just multiply these values, right? And you get your answer, whatever that is, right? We can multiply that. And then so this is 0.36, okay? And now you need to calculate all the conditional probabilities, right? So now the next question is asking you I'm sorry, B given D. So given that it's defect, it comes from B, right? And you need to also find out that probability. And then you need to find the probability of C given D, right? You need to find those two. So it's the same thing, except that this time, let me do that for you too. So this is taking time because this is, I'm explaining to you. If you do it just by yourself, you can do it very fast, right? Probability of B times the probability of B given B over the probability of B, the same denominator, right? The same exact denominator. So you can just copy the same thing. So this is that, right? And the probability of B times the probability of B given D is right here, right? So this is 0.35. So this numerator is gonna change. So this is gonna be 0.35 times probability of B given B is right here, 0.04. And that's gonna change, right? Whatever that is, 0.85 times 0.04. And the denominator was, I believe, this one. I think this one is divided by this denominator. You should get 0.40. And then the last one, because they're asking you three parts, right? A, this is B, and this is C, right? C should be this thing. C given D, right? Same thing, same formula, except that this time is going to be the probability of C, right? The formula will be like this: probability of C times the probability of D given C over the same denominator, right? When I say the same denominator, I mean this thing right here, right? So this is the same denominator, okay? Maybe move this out. So this is what I mean, the same denominator, okay? Now you know the denominator, what it is. The denominator computation is 0.0345. That's not going to change because it's the same. The only thing is changing is the numerator, right? The probability of C is 0.40 times the probability of B given C, that's 0.02. And that will give you your answer, right? So 0.40 times 0.02, 0.40 times 0.02, and this divided by this thing right here. And you should get 0.23 something, okay? Plus 0.36 plus 0.40. And if you add this up, this should be close to 1, right? So let me double check my answer key that I have already, because I already computed this before. And let's double check. Everything is right. The probability of A given D is 0.36. Probability of B given D is 0.40, and the probability of C given D is 0.23. That's correct. Okay. And if you add it up, the last one, we didn't even need to do that. The last one, we could just, if you know that this is 0.36, and if you know that this is 0.40, you can just add those two and subtract from 1, right? Because the sum of the probabilities must be equal to 1, right? So you could do that as well. So you will get 0.76, because this is a little bit, some decimals more, right? They will add to 1 after you subtract that, right? I mean, if you put in your calculator, you will notice that. Okay, so that's that problem. So you need to understand base rule, right? And the last part of this video is this thing, right? So we need to find true or false. That's going to be fast. Statistical inference is the process of making an estimate, prediction, or decision about a population based on sample data. Absolutely true, right? Two events are mutually exclusive. The probability of A union B is the probability of A plus the probability of B. That's true, right? This is what I meant, just in case. In a construction of a frequency distribution, it is a good idea to have overlapping class, such as 10, 20, 20. No, that's not true, right? You cannot have overlapping classes, because if we have, for example, if we have a sample data value of 20, we will not know where to, in which class will this 20 will be, right? Right? So we will have a problem. So the classes, they should not be overlapping. So this is false, right? It's a good idea. No, it's a bad idea. False, right? It is not important to keep the width of each class the same in a frequency distribution. You know, from the when we were doing this topic, you know that the class width have to be the same for each class, right? Each class has to have the same class width. So they're asking you, it is not important. No, it is important. So this is false, right? Okay. Data collect over a period of time can be graphed by using a pie graph. No, that's not true. We use a time series graph, right? We don't use a pie graph for that. This is false. A single extreme value can affect the median more than the mean. You know that that's not true, right? That's false, because you know the mean gets affected by large or extreme values, right? Or by outliers, basically, right? Remember when if we have 1, 2, 3, and 1,000, and I want to find, let me put another value here. If I want to find the median will be the value in the middle, right? Will be 3. Let me make it better, this thing. 4 and 1,000, right? The median will be 3. But if you find the mean is gonna get affected by this number that is an outlier here, right? So you know that the mean gets more affected by outliers than the median. So the median is more robust, right? The median is more robust. With respect to outliers, right? Okay, next. If a person's score on an exam, if a person's score on an exam corresponds to the 75 percentile, then the person obtains 75 correct answers out of 100 questions. That's not true. So when they're talking about percentile, with respect to this person's score, it means that this person scored 75%, 75. This person is above with respect to the other classmates. He did better, 75% better than the other people, right? And there's a 25%, 25% of people that score higher than this person. So this is with respect to where he's located, with respect to his score. So what I'm trying to say is that his score, he did better than 75% of the people that they took the test. That doesn't mean that he get a score of 75, right? And there's a 25% of people who score higher than this person. So he did better than 75% of the people who took the test, but there's a 25% of students or whoever took the test that they did better than him, right? So you have to keep that in mind. It's not the same. It's not saying that he gets 75, a score of 75. That's not what they're saying here. So this is false, right? So the mode and the mid-range are both measures of variation. No, the mode in the mid-range, we talk about that. That's in chapter 3. That's a measure of central tendency, right? So no, this is false. So this is false. Okay, the variable age is an example of qualitative variable. Qualitative variable, you know, it's you can label the like A, B, C, or you could just put name, right? Or variable age is numerical, right? So it cannot be qualitative. So this is false. And the weight of pumpkins is considered to be continuous. That's true, right? Because the continuous means you can weigh some object or some fruit or like some vegetable, whatever, and it's continuous, right? I mean, maybe it's 1.85 pounds, but we're just rounding at that point. It can be more than that, right? Or a little bit less than that. So that's continuous. So this is true. Okay. So that was the test. If you have any questions with respect to the test, just let me know. Or if something is not clear, just let me know. If you want me to go over the base rule problems that we did in class again, make a video on that, just send me an email and let me know. I hope you have a nice day and I hope you do good on the test. Good night.